Can you hear me? Everyone, can you hear me?
Yes, sorry about that, sir.
Okay. At least I have a feedback. Okay, so we start with question. We continue with question number 18. What is meant by escape velocity from the Earth? Tony, what do you put in your answer? Tony,
Me sir.
what do you put as the answer? Escape velocity from the
Uh,
Earth.
minimum velocity required for an object to escape the Earth's atmosphere.
Correct. Okay, that's a
Oh yeah.
there is the answer. Okay, uh, minimum velocity. Minimum velocity required by an object to escape completely from gravitational pull, okay, of the Earth. Yeah. Okay. So that's the answer. 18.
That's all I know, sir.
Okay. So actually, it's not very rigid. Okay, it's a loosen answer. 18A2. Is an expression for the escape velocity from the Earth which has mass m, radius r. So it's quite long because it has how many marks here? 7 marks, right? Oh, for 18. A. Start with we have the Earth, and then this is the R, R, small r, and then there will be bigger r when the outer space. So at that point, infinity will be this one is easier. This small r, this is bigger r. So infinity will be bigger, a smaller r. So r equals to infinity, and by conservation of energy, it will be half energy. Kinetic energy will be converted into kinetic energy will be converted into potential energy. Okay, 100% of the energy will be converted. So it will be 1 half mv squared kinetic energy. This is velocity of the escape equals to 0 minus negative gm small m over r. So actually this is the difference of the potential energy. This will be the change of kinetic energy. So left hand side kinetic energy, right hand side will be the change of potential energy. So it's a 0, right? But we have 0 because we are counting it is actually 1 over r, where r is infinity. So 1 over infinity is very big. It's a 0 actually, right? So from there we have PE. If you arrange the formula, PE equals to 2gm divided by r, where g is gravitational constant and r is the radius of the earth. R, radius of the earth. Okay, so we have finished number A1 and A2. Now we go into A3. Radius of the earth is 6460 km, 6400 km. Average field strength. What is the gravitational field strength? Field strength on the surface of the earth is 9.81 Newton per kilogram. Calculate the escape velocity from the earth. So we can use one more method, that is gm equals to gr squared. Okay, so escape velocity, that is the one we just derived, 2 gm divided by r will be equals to square root of 2gr. Okay, so if you substitute everything, you substitute the r, that is 6400 km, and you substitute also the g, the value of small g, gravitational strength 9.81, you have it is 11 km per second. Okay, so velocity needed for an object to escape from the surface of the earth is 11 km per second. Right, everyone got the answer? If everyone got the answer, you can put on the chat there, down there. Everyone, hello. Hello.
So what was the answer, sir?
11
kilometer.
11 km per second.
1,000. Yeah, correct. 1.12 times 10 power of 4 meter per second, same only, right?
Are you the one only in the class?
I'm one of many, sir.
Yeah, but others are not responding.
Yeah lah, sir, correct.
Okay.
I'm your second student now.
It's too quiet. Sometimes like I'm talking to myself. Anyway, at least
It's
I have
almost
two.
every day I talk myself.
Okay, at least we have two that's giving feedback to me. Okay, Mal, are you there?
Oh, Mel. Teacher, teacher.
Yeah, okay. Mel,
Yes, hi. Yes.
just asking, the rockets that we are launching to the outer space, right? The rocket that we launched to outer space, it it did achieve 11 kilometer per second or not? This number.
No.
Why?
Because.
But it just went to the outer space, right?
Yes.
So the reason is that?
Shit, I forgot. Tong, why Tong?
Shit, I forgot also.
Right.
It's because.
Wait, let me remember first. Wait.
Okay.
It's okay, so you tell us, tell us. You tell us, never mind.
Okay.
I don't think I can remember already.
The 11 kilometer per second is a once instantaneous velocity. It means that it was once before it was launched to the when they have a rocket. It happens once, means that it was moving 11 kilometer per second at a short time. But the rocket that we have, it is much more slower, but it will be it has a thrust for a long time. So it will be.
So this is question B1, right?
B3. No, it's question for A3. So 11 kilometer. If you let's say this is a ball, you kick 11 kilometer per second, it will be launched out to the space. But our rockets that's went to the outer space has lesser than 11 km per second. It's because the thrust we have a thrust for a long period of time. So that's the energy is accumulated to release the rocket from the Earth gravitational field. Okay, B1. B1. Three different rockets. Same mass launched from the surface of the Earth. At a point distant x from the Earth, the total energy of the rockets are represented by points P, Q, and S respectively. Okay, so there are three rockets over here, S, and we have a rocket of Q, and we have a rocket of P. Okay, and this is a graph of potential energy. Potential energy. So which do you think will be which rocket will be able to escape from the Earth by looking at the graph of potential energy over here? Tony? Mel?
Wait, so let me see this. Is it S?
Yes, correct. It's S because
I not sure either.
not sure. Okay.
I shot, sir. Tembak.
Okay. So you see, okay, the concept is the total energy. Total energy, as you see, is depends on two things. That is kinetic energy and potential energy. Right. Total energy depends on two things. That is kinetic energy plus the potential energy.
Potential.
Yeah, correct not? So you see
I
that
think so.
when the S is 0. Now you can see that the S over here is 0. Can you see the number? S is 0.
Yes.
Okay. So
Yes.
S equals to 0. The 0 over here is a value of potential energy. Right. So here, so over here, this equals to 0. It means that this kinetic energy is the highest.
Okay.
Okay. So
And
S.
we use Q or P have to minus, right?
So S is the one who escaped from the Earth. Okay. Now you see P. Okay, let's say P over here. P is the highest. Is the highest at potential energy. So how about the KE? KE will be the minimum or the lowest of that. So what do you think? What will be happen to P?
It will drop and crash onto Earth.
Yes. If the
Like my
surface
dreams.
it goes up and then it drops down like that. Okay, this is P. How about Q? How about Q?
It's like
It would-
halfway.
Yes, it's halfway and get that. Okay, halfway
Yeah.
up. Either it can escape or not. We didn't know. Okay. So this is the
So
case of
how you know that P will drop back onto Earth faster?
P will be reaching. I doesn't have the required energy to escape. Of course, it will fall down.
But Q,
Q either by momentumly it can goes up, or the radius of its radius of trajectory is bigger than P, like that.
okay.
But it didn't escape from the gravitational field. Maybe by momentarily or initially. You know inertia. If you remember inertia, it can escape. But I don't think so. Okay, it's 50-50. That's why the Q is down here in the middle. But surely that S will be escaped. Okay, we have done question number 18. Question number 19. Explain the meaning of term Young modulus, tensile limit, yield point of single wire. Okay, who can give me the answer for what is Young modulus? Young modulus is what's the Young modulus?
Yes, let me Google. It's a measure of the ability of a material to withstand changes in length when under lengthwise tension or compression.
Nope.
Not
Any more?
accurate,
No. Any more answer? Let's see. Let's see. I want to ask another person.
Okay.
Jeremy, not here. What's the Young modulus?
Ratio of tensile strength, tensile stress and tensile strain.
Okay, correct. It's a ratio of stress over strain. Okay, thank you. At least you are in the class. Elastic limit. What is it?
Elastic limit is after when the wire is stretched and the load is removed, the wire can come back to its original size, original form.
Okay, so when the force
extension that the
Right.
The length of the material still obey Hooke law.
Yeah, obey Hooke law, perpendicular, directly proportional to Hooke's law.
Okay, Malcolm. Job done already. Let's go.
Okay, the wire that obeys the Hooke's law, where the range where the Hooke's law is still obey. Okay, can you can use that term. Okay, yield point of pieces of steel wire. What is the yield point?
Maximum tensile strain that can be addressed by the material before breakdown.
Maximum. The maximum point?
Maximum tensile strength.
Maximum tensile strength. Okay. Or in other part, we can say that before plastic deformation occur. Plastic deformation occur. It happened before that plastic. Okay, thank you. 19b. List the quantities are measured in the experimental determination of the Young modulus of steel. State how each quantity is measured and how Young modulus is calculated from each measurement. How? I didn't. Oh, there you have. Okay. So we have a wire. Let's say we have a wire. Thing that we can measure is the length of the wire. We put as L, and the diameter of the wire, and we put as D. Okay, diameter will be D, and the length will be L. The extension, when we extend, we put as E, how it extend. Okay. Then we have a experiment. We put a wire, this say L, with the L, and we hang a mesh of it. So the mesh is actually a force pointing down. When you put a force, it will be equals to mg downwards. And after that, we have an experiment. We have a graph. So the graph will be graph of E over the mass, right? Extension over the mass. The higher the mass, the higher the extension of the wire. Okay. So uh, so determine the gradient. The gradient of graph we call as E against M. So we have E yang modulus equals to F over A divided by EL, E over L, okay, stress over strain. So it's a M mass, that is a force over E, and times with 4GL divided by pi D2. G came from the mg, this G it came from mg, and pi d square it came from the area of the wire. Okay, so m over E is actually the gradient over here, right? So gradient equals to E over m, so 1 over gradient is m over E. So m over E is actually 1 over gradient, so it is a 4GL divided by pi d square and times with the gradient there. So that's the answer, this one. Okay, take your time to copy if you need to.
Let me absorb, sir.
Okay, okay or not, Tony? Still absorbing?
Why me, sir?
No, you just said just now you want to absorb first. Taking time
Oh
to
yeah.
absorb.
Yeah, sure. I think I can already.
Okay.
More or less. I need to.
So we go to C1. What is meant by breaking stress? Ken, what is a breaking stress? What you meant by breaking stress?
Can.
Okay, so breaking stress is a max stress before the wire breaks. This is what we call as breaking stress. So goes back to the question 19C. We have a lift of mass 2,500 kilograms supported by steel cable. The maximum permissible load in the lift is 1,500 kilograms. The maximum upwards acceleration of the lift is 2.2 ms. So we have a lift over here. The maximum acceleration is 2.2 meter per second squared. The breaking stress of this cable is 1.0 times 10 power of 5. Okay, Newton meter, and Young modulus of the steel is 2.2 0 times 10 power 11 Newton per meter squared. Okay, so the maximum stress is equals to 1.0 times 10 power 5. More than that, it will break. Determine the minimum cross sectional of the wire of the string cable. Okay, so what will be the minimum cross sectional wire? So it came from T, the tension, minus mg equals to ma. So it's accelerate with A pointing outwards, and it was it has its own mass, that is mg, or the weight of the leaf, and the tension is pointing up, T. So T is positive and mg is negative. T positive because it has the same direction as the acceleration, that is pointing up. So T minus mg equals ma. So we have T is equals to m g plus a. You just reshuffle the equation on top, and then you substitute everything. Okay, you substitute everything. You have 1.0 times 10 power of 8 equals to m g plus a divided by a.
So the mass is 1500 plus 25, right?
The mass is 250 plus 1500.
Okay.
Okay, so divided by a. So then a is equals to 2500 plus 1500 times with g plus a, that is 9.81 plus 2.2, then divided by 1.0 times 10 power of 8. So the area is 4.80 times 10 power of negative 4 per meter squared. Okay, so 4.80 times 10 power negative 4 meter per squared. That will be the answer, the minimum cross sectional area of the steel cable. Okay, so next question, find the strain in the steel cable that when lift extends with the maximum acceleration. So number 3, the Young modulus is equals to stress over strain. So there you can find how much the value of strain over there. You just reshuffle with the Young modulus. So strain equals to stress
Tension over original line.
over Young modulus. You can use the Young modulus over here. The Young modulus have been given in the equation there. This one. So you can put the Young modulus inside here. So you have 1.0 times 10 power of 8 divided by 2.0 times 10 power 11. Then you have 5.0 times 10 power of negative 4. It doesn't have any unit. It doesn't have any unit. So left divided by dimension of length, cancel out by dimension of length. Okay, so time's up already. Okay, in the Zoom meeting. So see you tomorrow. We continue with the question number 20. Make sure you have done your second model paper. Okay.
Jeremy, you're there, Jeremy.
Jeremy,
What do you think?
You done?
What do you think?
If you done, you let me see. I want to reference.
Okay.
Okay, see you tomorrow, everyone.
You done, right? 100%.
Tomorrow? Not Wednesday?
Tomorrow, lah, bro.
Tomorrow.
Oh, yeah, tomorrow. I thought our next class is Wednesday.
Okay.
Teacher, I'm loser.
Hmm?
What?
Teacher.
Yes.
For the section, I'm totally wrong on almost all question in the selection.
Which question?
No, I miss in the selection camp.
Oh, you have your marks. How many marks you have?
I only get roughly 60 over 150.
Oh, less than a half.
Yeah,
How about the others? 150.
highest is 85.
Oh. Okay. Never
What,
mind.
sir?
You have the next year. For the
So
next year,
they
you have, right?
decided to select again, that's why.
Okay. So the meeting will be ending right now. So I have to stop.
Okay, sir.
Okay.